Hi, and welcome back to another LeetCode video. Today we're looking at another math and geometry problem from the LeetCode 150 list. This is LeetCode 2013 Detect Squares, and it's a medium problem. So let's read through it to understand what it's all about, and then we'll try to solve it. So we're given a stream of points on the XY plane. Design an algorithm that does the following. Adds new points from the stream into a data structure. Duplicate points are allowed and should be treated at different points. Given a square point, counts the number of ways to choose 3 points from the data structure, such that the 3 points and the query point form an x-axis aligned square with positive area. An x-axis aligned square is a square those edges are all the same length and are either parallel or perpendicular to the x-axis and y-axis. Implement the detect square class. Okay, we have a template here for that. With a constructor that initializes the object with an empty data structure. A function or method add that adds a new point, and the point is given as x and y coordinates to the data structure. And a method count that receives a point and should count the number of ways to form x-aligned squares with the point x as described above, right? Okay, that's a mouthful. So basically, we're going to get points that we need to store somehow. And when somebody calls our count method, we should return how many squares can be formed with that point that is given to count and all the points that we've already added to our data structure. So here's an example. So we have 3 points, and then I guess the query point is here, and then there is actually a result here. Now, if the query point is here, we cannot form a square, obviously. And yeah, okay, so right. Interesting. And it's guaranteed that all points are all coordinates of x and y values are positive. Okay, well, how can we tackle this? Well, we're going to be able to need to determine how many, so duplicate points. We need to be able to count duplicate points, right? So I think maybe that's the first step that we can solve. So we could store like a hash map that counts, or dictionary that counts how many points there are given a specific x and y coordinate combination. So points, we're going to have I guess we use a default dict. And we're going to set it to int, so we're going to use it as a counters. And when we add a new point, all we do is we say self.points. And well, lists are not hashable, right? So we have to actually extract the x and y coordinate from the point. And then we just put it in as a tuple. xy. And we're going to increment the counter by 1. Okay, cool. So now when we have to deal with duplicates, we know how many we have, right? So that might be the first step. Now, the next question is, how are we going to store these points effectively? And we can exploit the fact that we are dealing with squares. So if we have a point in our data set, and or if we just have let's say we store all points as a dictionary where the x coordinate is maybe the key and the y coordinate is the value, right? Then it becomes very easy to look up all the different y values for a query point that we have. Because the query point needs to be aligned with either the x or the y axis. Right? If there's no other point that is on this, that has the same x coordinate, that means we cannot form a square. Same is true for the y coordinate of the point. If there's no point that has the same y coordinate as our query point, we can never form a square, never ever. So it doesn't really matter if we use the x or the y coordinate as the key, but we need to be able to pull out points that have either the same x or the same y coordinate. And that will be the core idea of our lookup. So let me just add this data structure here. Self dot coordinates equals default dict. And well, I guess we can use a set. So every time we add a point, we just say x at y, right? And we don't really have to do anything else for our initialization and for the add methods. Now, if we get a point, well, what do we do then? Well, obviously we need to compute a result. I'm gonna add that as a template. And well, we need to pull out the x and the y from the point array. And now what we can do is we can get all the different y positions. Maybe we should call it from the point x1 and y1. Now we can pull out all the other y positions that exist in our data structure in self ports at x1. So and if there are none, then that means we cannot form a square, so we can immediately return a result. But if we find values, that means that, let's take this example. So where the orange square here is the query, and the round ones are the ones in the data structure. So what would happen is we pull out this y coordinate from our data structure, y2. So now we have at least another point on a line that is perpendicular to the y-axis. That's what we pull out. Now, we also know what the width and the height of our square is, because this is a square, so we can compute that. And we can also look up, well, we can compute the x position of this point and of that point, and we can just look them up. Now, do they exist in our data structure or no? So that way we start from a query point, find points that have the same y coordinate. We compute the next x coordinate through the difference here between the two y coordinates, and do another lookup. And then we have to do another lookup to make sure that we have different points here as well. A point on that matches with the query node on that axis. So that is how we do that. And we're going to use the fact that we have a pointers counter to compute how many different ways there are to form squares with points that we've added to our data structure, including duplicates. That's kind of the core idea here. Let me just show you how that looks in code. Well, the first step is, well, what is x if y1 is the same one as y2? Well, our little square is going to fall flat. It has side length 0, right? If that is the case, well, we can't do anything, so we're going to continue. We're going to ignore that y value, right? If the orange square was in our data set and not a part of the query, and then it comes in as a query again, that point needs to be excluded from computing the results. So, well, how are we going to update the results? Well, we have to count, how many points we have. So first thing is we could calculate the side length, right? Side length of our square. Maybe we should call this n. And we're just going to use the absolute value between, well, y1 and y2, right? Now, result. What is the result? Well, we have to compute how many points are on these other coordinates, right? And that's exactly what we'll do. We'll count the number of points that are on x1, y2, and we're going to multiply that with the number of points that we have on which coordinate? X plus side length and y1. So this should be x1, right? So now we're taking a step into the, I guess, positive x direction. And we have to multiply that with the number of points that we have in the x1. Sorry, y2 and x1 plus n direction, right? We are giving a point, x1, y1. The other points are, well, we could also compute them. Like x3 is basically x1 plus n, and same the x1. We should draw this, make it a little bit clearer. So if x and y, giving a query point here with x and y. Now what we're computing is we're computing this one, x1 plus n at y1, right? This is x1, y1. And we're also going here and we're going where, right? So we need to compute this point. So that's going to be x1 and y1. Sorry, y2. This is the point that we pull out of our data structure, the y2 point. And then we have here x1 plus n and y2. So you can see we have to compute this and we have to compute this. We already have this point, so we just need to compute those two basically. And yeah, and that's what we do here. This is for those two. Right. And then, well, we also have to take into account that, you know, the square might be into the different direction. So what we do is we do minus n to the minus n. Just because we have, well, this is going to be our n, right? So the square between this point and the point that we pulled off our data structure is either in this direction or it's in that direction. So we kind of have to check, you know, how many are there and how many are here. So this is first, how many squares do we have to the right? This is how many do we have actually to the left. Yeah, and that should be everything that is needed, really. I think that's everything. So let's test this. Function point call is illegal. Self.points. Oh, I see. I need some square brackets here, and that applies to here as well. Because I'm using the tuple as a key. Good, let's try again. That needs to be equals equals. So it passes the test. Let's submit it to see if it passes all of the tests. And it does, very nice. And now let's do a quick runtime and space complexity analysis. Obviously the initialization is of 1 time and space. Adding a point, you know, is of 1 time, but it increases space, of course, by 1. So n times adding something will result in O of n space. Now the count method is maybe the most interesting one because now we need to loop. But here the looping is just one loop. And this is at most O of n, you know, that is when all of the points align with x1, all of the points that we added to the data structure. And that's the worst case where we need to loop over all of them. Everything that happens inside the loop, the for loop body, is again constant space and constant time. So here we have O of n time. And add method is O of n space when it's called end. And yeah, solution.